All right. So solving literal equations basically is just rewriting equations in a different order. You'll be okay. So we're going to rewrite an equation with a certain variable by itself. We're going to use the same inverse operations to solve these as we've done all those other equations. You want to join us? Yes, sir. Okay. All right. So these first few, we're going to do the same thing on. We're going to solve for y, the variable y, on these first 3 or 4 here. 5 actually. So first example, something fairly simple. 3x plus y is equal to 8. And we want to get y by itself. So we're solve whatever letter you're asked to solve for, you want to get that letter by itself. So what you look for is you say, okay, well, what's not a y that's on the side y is on? Well, on this side we got a 3x and we got a y. The 3x is not a y, right? So we need to get rid of it. How would I move a 3x?
Subtract 3x on both sides.
Yeah, subtract 3x on both sides. There's y by itself now. These on the left side, the 3x's cancel each other out. And on the right side, we've got either 8 minus 3x, or the way I'm going to write it is negative 3x plus 8. It's kind of standard practice to put the part with the variable first. Okay. Remember in 8th grade, y'all, or whatever math class you had last, you did slope-intercept form, where that's what we're headed to next in chapter 4. That's where we're going. So I'm just going to go ahead and start writing my equations that way if I'm solving for y. Just write the letter part first and then the next part. And that's a positive 8. That's why it's plus 8. And we've got y by itself. We're done. We're not getting y equals a number. We're getting y equals some stuff. Okay? For that problem, yes. Because is a 3x and an 8, are they like terms? Good. No, they're not. That's a really good question. Because this has an x and this doesn't, you can't put them together. If you did have like terms on that side, yes, you would reduce, put it together more. That's perfect. Yes, because they're different. They're not like terms because they're different. The only things you can put together with addition or subtraction are like terms, things that are the same variable, same exponent on that variable. So look at one like this, 2y minus 6x equals 18. And again, we're still solving for y. Those instructions haven't changed on these first 5 we're doing here. Okay, so we're going to solve this for y. What on this side here is not a y? The 6x. How do I move it?
So you would add 6x.
All right, yeah, I'm going to add 6x because they're subtracting it. The opposite of that, add it. Now that gives me 2y equals 6x plus 18. Now, is y by itself? Not completely. It's almost. It's got a 2 on it. How do I get rid of that 2? Divide everything by 2, absolutely. So I'm going to divide each individual piece by 2. They cancel out on that side, just like we want them to. There's y by itself. Then we try to reduce those fractions. Does 2 go into 6 evenly? Yeah, so it's 3x. 2 goes into 18 evenly. 9 times plus 9. There we have y by itself. Literal equations mean you're going to get an answer that's not just a number. It's going to have some other stuff in there with it. Okay. All right. Let's go to another one. 10x minus 4y equals negative 16. And again, we're still solving for y. And change that direction yet. We'll get y by itself. So what do we move first, Abel? Which one? Yeah, we're going to move the 10x over there because this side has the y on it. The other side doesn't. So I need to get that 10x out of the way. So we're going to subtract 10x from both sides. Yeah. This is annoying all day. Yeah. There we go. All right. So now is y by itself? No. What do we got to do to get it there? Not by just -4, not by just 4, but -4. Don't drop that sign. That's a pretty common mistake you'll see. Folks, when they come down here, just put 4y instead of -4y or forget to divide by the negative. Dividing by that negative, it's going to cancel out the -4s there. That's y by itself. Negative divided by negative is going to turn into positive 10 over 4. Does 4 go into 10 evenly? No. So we're going to reduce that improper fraction. 10 and 4 both divisible by 2. 2 goes into 10 5 times, into 4 2 times. So that's 5 over 2x. Does 4 go into 16 evenly? Yeah. How many times? 4. And that's going to be a +4 or a -4? +4. Why is it +4? Double negative. There's -16, -4. That's what causes that to be a +4. And there's our y by itself. Okay, so not terribly difficult so far. Let's go to the next one. Well, you would have to need to know what x was to get a number there. If they told us x is 4, we could plug 4 in for x and work that out and get an answer. Yes, there's things that we could do after this. We'll do that in chapter 4. We'll take that and actually do some stuff with it. All right. 5y minus 15x equals 2x plus 35. Stepping it up just a little bit as we go here. Michael, what would be my first step? Add 15x. So we're trying to get y by itself. So we want the y's on one side, everything else on the other. So adding 15x. What do we add the 15x to? Why? Same types. Like term is the math word for that. Like terms. 2x and 15x together would be 17x plus 35. And we got 5y over here. Last step. Divide what by 5? Everything. Good. Does 17 over 5, does 5 go into 17 evenly? Does it reduce? No, 17 and 5, nothing goes into them except for 1. That doesn't reduce it any. So we're going to leave it that improper fraction, 17 over 5. And then 35 divided by 5 is 7. So no mixed numbers in stuff today, okay? Not going to have any mixed numbers in your answers, okay? You're going to leave them improper fractions, but reduce them as much as possible. But don't change anything to a mixed number, okay? That's what we're going for there, okay? Not too bad. Let's do this one. Let's say we had 4y minus 6x equals 7x minus 2y plus 18. A lot going on with this. This is as hard as they get, really. Michael, can you help us? Okay, he says add 6x to the 7x. Is that a legal move?
Yes.
Yeah, it's legal. And does that have to be your first step, though? No. What else could we have done? Yeah, I could have added the 2y to move it over there. It doesn't matter which one, guys. What Micah said is what I'm going to do because that's what we said first. But it doesn't matter which one you move first. Just get the y's to one side, the x's, and everything else to the other. So adding 6x works great. Gets you 13x minus 2y plus 18, and then this side's 4y. And then you guys said you could have added 2y. Well, now's the time to do that next step. You add 2y to the 4y. Why are we adding 2y and not subtracting 2y? It's a negative. We're moving it to the other side, so it changes signs there. So that's going to be 6y, 13x plus 18. Divide everything by 6. Last step. Does 13 over 6 work? Does it reduce? We leave it 13 over 6x plus what? 3. 18 divided by 6 is 3. We're left with that. Y by itself. Okay. All right. Let's do a really fun one. Yeah. No numbers at all. Again, we're going to still solve that for y. Because we're kind of in that idea right now, and then we'll change to some other kinds of equations. Abel? Okay, good. This does not have a y, so Abel said, let's get rid of it. Let's subtract it. That's right. So that cancels out on that side. Leaves by. And then I'm going to write it negative ax plus c. So that I've written the part, this kind of like we did on every problem before this. Now, what's going on between the b and the y when they're written like that? They're multiplying. The opposite of that would be division. So we're going to divide by what? B. Well, that's the thing. They're letters. They're not numbers. So there's really nothing we can do other than just write it as a fraction. So leave it negative a over b plus c over b. When I subtracted, you said subtract a to get it over there. So when I subtracted, it made it negative over here. So that's where that negative came from. Good question. That's one right there. It is easy. Let's change it up a little bit. Let's get to some different kinds of problems. We're not just solving for y all the time. Sometimes we might have a formula that's pretty familiar to us. Length times width is equal to area. Okay, so that's the area of a what? Area and perimeter can't be the same. A rectangle, right? Or it could be a square. Length and width would be the same there, but it's an area of a rectangle. So if we wanted to solve this for W, what would we do to get W by itself? Say that again. Divide by what? L. Trying to get W by itself, so we divide by L because that was length times width. The opposite of multiplication is division. So we're dividing by L. Area divided by length is width. Okay. And this would be one of those scenarios where maybe you're solving for that so that you can find, if they gave you an area and a length, you could find the width really quickly because you got a formula for it. Handy. All right, let's look at this one. Somebody said something about perimeter. Let's use that formula. That's a good one. Perimeter equals 2L plus 2W. Let's solve that one for L. Okay, so we're trying to get L by itself. So this is what we're trying to get by itself. So what do we do first? Somebody, very good. Subtracting 2W because that's not an L. So here, there's so many variables, it really doesn't matter what order you put that in. I'm going to do the easy thing, put P minus 2W. If you wrote negative 2W plus P, that's the same thing. I wouldn't count it wrong. What's the next step? What divide by 2? Just the 2L? Everything. Every piece gets divided by 2. And then you reduce the ones that will. So this one goes away. There's L by itself. It's on the right, but it still works. P divided by 2. What's really in front of that P? 1. Does that reduce any? No, it's just 1/2, right? 1/2 P. 2W divided by 2 is 1W, or just minus W there. That's L by itself, so that means we're done. You might feel more comfortable if you wrote it this way. With the L on the left side, that's the same thing. It doesn't really matter which side your variable you're getting by itself is on. You may even see it written this way. P divided by 2 minus W. That's the same thing as 1/2 times P. Those are the same. So be aware that that may be the case. All right. Let's get this one. D equals RT. We're going to solve for T. Anybody know what that formula is? Distance equals rate times time. Distance equals rate times time. So like rate being like miles per hour, how fast you're driving. If I'm driving 30 miles an hour for 2 hours, how far would I go? 60 miles. That's what that formula is used with. Okay. If we want to solve that for T, what's the step? All right. What would we already know what the example is? What do? We divide by R. D over R equals T. And I'm going to reconnect. We got just a few more to do. And she's not going to reconnect. Awesome. Get that. And it's not going to connect. It always works. There it goes. Okay, we'll do the last ones on here, if possible. What letter are we on here? J. Simple J. All right. C equals 2 pi R. We want to solve for pi. A little bit different because we're solving for pi. We normally think of pi as being what? 3.14. That is a rounded value for pi. We're going to find out what pi really is. Good idea. But what's going on between 2 pi and r? They're all being multiplied. So the undoing of multiplication would be division. So we're going to divide by what? Just 2 or r? 2r. Both of them are being multiplied, right? So to get rid of both of them, we're going to divide by both of them. So we would divide by 2r. These cancel just like they're supposed to. C over 2r is equal to pi. What's 2r? Does anybody remember that from talking about circles? It's 2 times the radius, which is the actually called the what of the circle. The diameter is all the way across. 2 radii would get 1 diameter. So pi is really the circumference of any circle divided by its diameter. That's what pi really is. And it always works out, if it's a perfect circle, as being close to 3.14. And or 22 over 7 is actually closer than 3.14 is. But pi has, one of the ways they check how fast computers or iPhones or whatever are, the chips, is they get them to calculate pi to 1,000,000 digits and see how long that takes. Because pi never ends, it keeps going. But they try to do it that way, which is pretty neat. All right, let's get K. Example K. Let's do A equals 1/2 BH. 1/2 base times height. What is that the formula for? Triangle. What of the triangle? The area of a triangle. Yeah, A is the area, B is the base length, H is the height of that triangle. Let's solve that for the base. Maybe we can do this one in 2 steps, probably would be better than 1 step, most likely. Because that 1/2, that fraction in there can cause us a problem. How do we get rid of that 1/2? Divide by half, which is the same thing as multiplying by the reciprocal of a half, which is 2. If I do that, I get 2a is equal to bh. And then divide by h. 2a over h is the base. Times the area divided by the height is the base of a triangle. So they're going to tell you which letter they want you to solve for. Some of them you're going to get some practice solving for y. We're going to do that a lot in the next 2 chapters, solving for y and working with equations like that. And then the others are going to, the formulas that we've been working with here, they're going to tell you which letter to solve for. And you just get that one by itself using the inverse operations that you guys already know how to do, because you guys know how to solve equations. We've been doing it for a month and a week. So you guys are doing pretty good with it. So your assignment for today is on page 187 in your book. (11 through 28), and then 32 and 33. All. Yeah, evens and odds. Okay. So working by yourself on this, get started with it. We've got 20 minutes or so before lunch.